So unit testing is code that is going to run a piece of code against our code, which is going to verify and validate the requirement of our application. So we are not going to focus on the theory a lot. We are going to jump right into the Visual Studio Code. So let me launch an instance of Visual Studio. All right. I'm going to start with a simple console application. Let's select a console application from the recent items, and I'm going to move it to my regular code folder and call it unit testing demo. I'm okay with .NET 5. Alright, let's do some boilerplate code for our application. I'm going to hit control dot, and then it is going to give me a tooltip for creating this class. Control dot, and it will generate the app class in a new file. And I'm going to do app.run, and with control dot again, it's going to generate that method. Both the class and the method, they are internal. I can leave it internal and then show you a thing a little later. Now, this application is supposed to work with another. The example that we are taking is that of a calculator. So a calculator is going to be a public class, and we're going to have a public method on it, which will simply return integer a, the addition of these two numbers. One syntax that I did not show you till this point is that when you have a single statement inside a function, you can reduce it in, I think starting using C#8, you can reduce it to an expression bodied member. And this code here is what this code is equivalent to this code on these C lines. So we have gotten rid of the parentheses, the curly braces, I'm sorry, and the return statement, right? And we have replaced it with the lambda expression. These are expression bodied members, and it is going to do the same work as this function. If you have a single statement, you can use the syntax. So we have a calculator that does addition of two numbers and returns the result. Now, to use the calculator class in the run function, we can create the calculator object, and then call calculator.add and pass it two numbers. So rather than passing these two numbers here like this, let's go ahead and read those numbers from the console. Now, the function that we're going to use, it is going to be readLine, and readLine is going to return you a string, a nullable string. Now, that string value we can save in a string, in a variable like this, and we can change this value to a string using another method on integer, which is parse. If I pass a string value to this, it is going to return an integer object to me. This parse function is available on multiple classes, including datetime, say string, float, character, and then you can convert these numbers around. Now, I'll require a second value, so I'm going to repeat this section. Control E, Control V is going to duplicate the selection, and I'm going to change this to Y and this to Y as well. And it would be nice to see some handy message, something like this: enter value of X and value of Y. Now I can pass x and y to this function. Nothing fancy till this point. If I execute this code with Control F5 and print this output window, if x is 10 and y is 20, the result should be 30. We are not printing that, so let's go ahead and do that. Add result, and to use it in line, we'll have to put a dollar sign in the beginning. And now if I hit Control F5, once again, 10 and 20, the result is 20 again. Let's go ahead and see what we are doing inside the add function. Did I do Right, I might have to put this thing inside places. Let's give it another shot. Alright, give me one moment. I'm going to comment the rest of the line and do uncomment these three lines here. And then notice this tooltip. It does not access instance data converted to static. Alright, I was checking if the tooltip here is going to give me an option of converting this code to the expression body code. It is not. I might have to put a breakpoint on this line. Enter these values again. Def 11. So x is 10, y is 10. Yep, obviously, because copy paste is a little tricky. You should be very careful when you're doing copy paste. This should have been y value. Right. So with that, I can go ahead and comment this out. Control key, Control C is going to comment the selection. And if I delete these lines, now it'll work for the input. I'm going to do 10 and 20 again, and I'm getting 30. Let's try a couple of more values. If I do, say, x is 0 and y is 5, it should return 5. Let's try with some negative values. 5. If this value is 5, this value is minus 5, the result should be 0. Alright, so this code, it seems to be working. But then what we are doing with this application is we are manually testing it. And manual testing is a little tricky. You will have to come up with a test strategy, a test document, and that document is going to outline a lot of things like what section of application you are checking. So for a calculator, I'm a QA person, a manual tester. He might come up and start mentioning stuff like this. You are testing a calculator, you are testing the add functionality, what scenarios you want to test, positive numbers, what scenarios you want to test, negative numbers, right? What if you pass all zeros? So testing generally happens across the entire spectrum of, of the value range that you can pass. And then you can see that there are limitations to this. You can try a couple of cases, like for positive number, you're going to say, I'm going to try with 5 and 10, and the result should be 15. I'm going to try with, say, 10 and 20, and the result will be 30. So a QA person, on a day-to-day basis, they're going to create test plan, test strategies of the application. But um, this is going to be a lot slow, and eventually your managers, your client, they would expect that testing should be done faster. And a strategy for doing that is you start writing code once you identify these requirements, once you have the strategy, you write code against it, right? You don't manually go and enter the values the way we were entering here. You start providing these values as a part of application code itself. So we're going to add another class, and I'm going to call it calculator tests. And you know what, I'm going to change this name just to match with the second part of our application. We're going to say calculator should, and I'm going to write a void function here which will say add positive numbers, right? And then I'm going to delete this part as well. In this function, I'm going to create the object of calculator, and like so, and I'm going to call the add function on this. So we're going to pass two numbers to it, we're going to get a result from it. So we can do this like 10 and 20, and we're going to get a result from this. What we can do is if result equal to 30, we can print that it passed. Make sense? Now all we have to do is we have to call this function from our application, or we can probably do it from the main function itself. So we are not going to call this code. This is our calculator's production code. We are going to create a test class, and we're going to call it a calculator should. And I can actually rename this test class to the calculator should. Calculator should add numbers, and then add numbers probably right now is private, but then on a private member, if you hit F12, it still takes you to that definition. Interesting. uh, because I'm using the wrong case. So if I go to add number, it is going to execute this function, and now from the main function we are calling our test code. If I execute this code, it is saying that it passed, but it is not very helpful, very handy at the moment. What we'll do, we are going to modify our test case. Let me rename this file as well. I'm going to start accepting numbers integer x, integer y, and we are going to simply pass these values of x and y to the actual production code, and we are going to expect a result. Now probably we should also expect the result from the outside, and because this result is going to contradict with this result, I'm going to change it to expected result, and I'm going to change this one to actual result. And let's change this condition from equal to 30 to expected result, and only in this case we are going to write passed. And let's go ahead and add an else statement as well, and repeat it. And instead of calling this number without parameters, we are going to do this thing in line. So add numbers 10, 20, 30, and let's repeat this a couple of times. If it is 5 and this number is also 5, the result will be 10. If one of the numbers is 0, the second number is equal to the first number. We change it to 3 and 0. And let's add a couple of test cases for negative numbers as well. So if it is 10 and negative 20, sum will be minus 10, and if it is minus 5 and 5, it will be 0. Right? Now if I run this application, right, all of our test cases are passing, which means that the calculator is working for positive numbers, it is working for with a 0, it is working with negative numbers, probably it will also work with all the negative numbers. Right? What we have essentially done, we have taken a piece of code we have written that code, and once we thought that our application is complete, it is doing what it is supposed to do, we went ahead and started testing that function using automated test cases. Now, running this code is fairly straightforward compared to providing inline values like this, because manual intervention is subject to human errors, right? And it is time consuming. This test case here, through these values, these hard-coded values being passed to the system, they are going to happen a lot faster. The only problem is that we currently are not relying on tools. We are building this manually. There is a better way of doing this thing, and for that we have a project type. Now, if I right clicked on the solution, selected add project, and over here I'm going to select unit. There is an option of unit test project. It is going to use ms test unit. Then let me go ahead, instead of unit I'm going to type test. So there is ms test, there is nunit test, and there is another unit testing project template possible, which is xUnit. Now xUnit, it is open source, and it is derived from the nunit test cases. They all are going to do the same thing. For our session today, we are going to use the xUnit test project. I'm going to hit next, and I'm going to have it match to the solution name or the project name. I'm going to call it unit test cases, right? Let's hit the next button. .NET 5 is fine. I'm going to select create, and it has added a new project with the name here unit test. Now I want to match this name with the functionality that I'll be testing. Because it is calculator, I'm going to call this one as calculator should. Because I'm renaming the file, it is also going to rename the class, and then the class name has also been changed to match the file name. We can have the same function name here, and we can call it add numbers. And inside the test case, we are going to do the same activity that we were doing here. So once again, let's just go ahead and copy this code. I'm going to pick up onto these two lines and paste them here. So we have a calculator object. It's going to complain right now because there is no reference added, and it is suggesting us to add a reference to the unit testing demo. I'm going to select this. It is going to have the effect of adding a project reference here. So keep an eye on the solution explorer, and if I do that, it adds a project reference here, I guess. Right. So this reference get added using statement here, using a unit testing demo. Right. And now we have to pass two numbers to this. The way we're going to do that is we'll create the values in line, variable x, var y, and once again we are going to have an expected result, say 30. Now this unit testing framework, instead of comparing manually using the if block, the unit test case project, it gives you a type called assert. Right? It is part of the xUnit. If I go to the definition of assert, you're going to see the comment says contains various static methods that are used to verify that conditions are met. Right? So it has the assert class has a bunch of static methods. All collection, it contains, it does not contain, then there is empty, uh, ends with, equal, multiple equal implementation. Then if there is equal, I'm assuming that based on what we are seeing here, there should be a not equal, right? If there is a function for contains, there's an equal pair that it does not contain, and then contains, it takes a generic type t, and this t, it could be compared against a collection. I'm looking for a couple more. Right? It checks for false, that the parameter that we are going to pass in is going to verify if it is false, and if there's a false, there should be a true as well. So if we keep scrolling down, you're going to see an implementation for true. Right? So let's go ahead and put this to use. Assert dot, I'm going to choose the option of equal, and we want to compare two numbers to be equal. The expected result, and then it is suggesting like 9 implementation of equal. The first variant take string, but we have it for daytime, we have for decimal, double, string, and then some collection classes as well. So let's go ahead and provide the expected result here and the actual result over here. Now, the way to run a test case is, number one, you can right click and you're going to see two options: run test or debug test. There is another option called create unit test and live unit testing. We're going to see this very shortly. In the view menu, or probably in the test menu, we are going to see a test explorer. Let's see if it is available in the test menu as well, and it is present here as well, test explorer. Once we open this window, it's going to launch a window like this. Right? Let me go ahead and tuck it to the bottom, and it has gone ahead and created this selection here, and the name matches the namespace here. If I scroll this thing, if I expand these labels here, we're going to see that there is a namespace, unit test, test cases, and then there is the class, the test class that we have just provisioned. It's called calculator should, and inside calculator should we have a test add number. Right? Now, if I click on this button here, it is going to say run all tests, or again right click on this and say run. It is going to execute this single selected test case, and now when the test case completes, it's going to say that all the test cases they have passed. Let's go ahead and execute it again. Right. Let's go ahead and make this test case fail. So I'm expecting a result of -30, and now if I run this code, it's going to return a failure. Let assert equal on this particular line, it failed here, and the error message will be displayed on this side of the window. It's going to say assert.equal failure. The expected result was -30, but then the actual result that we received was 30. And then the stack trace is showing the line where this error has originated. So if I click on this, it'll take me to this line here. So this particular assertion has failed. So we're going to go ahead and correct this element here, and let's go ahead and repeat this. Control E, Control V, add numbers 2. I'm going to say this time I'm going to give 5 and -5, and the expected result is 0. But then now if I rebuild the code and go to the test explorer, right, the test explorer, it is not listing the test case, and that is because of this attribute here. If you want to write a code which is available in this list, you will have to modify the test case with this attribute, a fact. So all the facts, they start appearing here, and now you can see that it got added to this explorer here. And notice the icon here, it indicates that it has not been done so far. Again, there are multiple options available here. This is simply going to run all the test cases, but then if you click on this down arrow here, it is going to give you an option, not run test cases, and it is only going to execute that second test case. Right? And this time only this one passed, and it is indicating that it did not fail still, because 10 and 20, 30. Okay, so this failure is from the last time. Because we did not run it this time, it is still displaying the result from the last time, but you have an option of running these together. Now, as your application grows, you're going to have more and more test cases, and you might want to have some form of categories in these test cases. So this way is a lot better of running your test cases compared to this one, because over here you will have to rely on comments in different sections, and it is not giving you the flexibility of a test explorer. Now, just to see the power of unit testing or these frameworks, we are going to add a couple of other keywords over here. There is another attribute called trait, and to trait we can give different filters. Again, one of the filters is category, and it takes a key value pair. It takes two parameters, and the value of this is, say, add methods. Now, all the tests that we are all the tests that we are adding here, we can modify those test cases with this attribute. So I can come here and then say this one is testing an add function 2, this one is testing an add method 2, because we are probably in the future hoping that there will be, as we complete the calculator functionality, we're going to add the subtract, multiply, and divide function as well. If you only want to test the add functionality, you would want to have some form of category in these test cases, and there is a little icon in the test explorer which is group by, and if I click on this group by icon here, it is going to give me an option of trait, and over here we see all the add methods, they are tucked together under this category here, right? And you can right click and you can run only this particular set of test cases. So if you want to only test the add functionality, you can create a category and it will run only those test cases, those 3 test cases, right? There is a nice handy output here which is telling the duration, like the duration it took for the execution of these test cases. It is giving you the category, and it is, in case of failure, probably it is going to also put a nice friendly error message here of which of these test cases they failed. Now we see that there is a lot of repetition here, like 5 and -5, and they are all doing the same thing, right? It's the same for this test case as well and this test case as well. All we are doing is we are changing the parameters or the input to the add function and the expected result. We would want to have something similar to this, where we are in the program where we are passing different value to the function without a lot of repetition of coding, right? Because one of the coding principle is that you should not repeat the code. So every time you hit the paste button, you should take a pause and you should think that is there something that I'm violating, and is there a better way of not repeating or copying the code? So we're going to get rid of this section here, and the way we have the fact attribute, there is another attribute which is called theory. A theory is a test case, but then it expects that the function must have some input test data, right? So as soon as I added theory and removed fact, the code started to break, and it is saying that theory method must have test data and it should have parameters. Those 3 parameters, they're going to look exactly like these parameters here. So let's go ahead and copy this into a test case here, like so. And for providing test data, there is another attribute, it's called inline data. And this inline data, it takes a param object. So if I go to the definition of this and read through the data values to be passed to theory, and it is a collection of objects, so you're not limited by the type of the parameter that you want to pass. So we're going to pass 10 and 20 and 30, we're going to get assigned values in order. So it's saying that parameter is never used. I'm going to get rid of these 3 lines. Just going to comment it, and the rest of the application is going to work fine. Now if I want to repeat this scenario, I can do this, and probably just complaining that the data is same as before, right? It has duplicate data. So let's go ahead and change that. So 5 and 5 should give 10, and -5 and -5 it should give -10, and then 0 and 10, 0 and 20 probably will give you 20, and 10 and 0 will give you 10. Okay, so I we got the drill. We are going to add all the inline data here, and now if we look at this section, it is saying that add method, it has 5 test cases available. It will be tested 5 different times. And now if I execute these 5 test cases, all the test cases are passed. But let's go ahead, add another line. I'm going to say 0 plus 0 is going to give me 0. Right? Now let's go ahead into our actual production application, the super complex calculator, and instead of x plus y, I'm going to change this to x into y. Right? Now if I run this code, run all the tests again, all the test cases are going to pass except fail except one. Right? This test case here still passed because this test case is running for this input here. 0 plus 0 is 0, and 0 into 0 is also 0. Right? And that's why this test case has kind of failed. And this is very crucial as you are writing automated test cases. Just because one of the test cases is passing, it doesn't mean that your production functionality is right. The code that you are writing, all the test cases should pass, because there could be some overlap in the results that you get. And that's why the test data that you are going to provide for against this automated test cases, they should cover the entire spectrum. They should start on the extreme left. They should test a couple of cases between the extreme left and the 0 case. Then you should have some testing for the middle, and then you should test on the other spectrum as well. So we are testing with all positive numbers, we are testing with all negative numbers, we are testing 0, and we are testing a couple of values in between. So this is a good enough test case. But one of the thing about test cases is that you can never be confident about the kind of testing or the test results that you're going to give. And the reason is integer has 4 GB values. Like if I go to the definition, notice the minimum value and maximum value. If you want to write a function, you will have to test all these 2 into 10 raised to 12, or 2 GBs of value on the negative side, 2 GBs of value on the positive side, and this test data here is going to look a lot bigger. We don't provide the entire spectrum of all the possible values of integer x and integer y and the integer expected result, because that's going to mean 4 GB into 4 GB, 4 giga into 4 giga into 4 giga, right? It is going to be a humongous number of test cases, and you cannot do that. And that's why testing never says that you are positive, that there's no defect. You're going to see that based on the test cases that we have executed, we did not find a defect. A test case does not say that testing is perfect. Testing says that we did not uncover any defect so far, right? And probably it is good to use, but then you might want to test at your end with some of your test data as well. Right. So with that, I'm going to introduce you to another theory, and that theory is called test-driven development. Okay, so the official word is TDD. It stands for test-driven development, and sometimes it is called test-driven design as well. What we have done so far is we created a calculator application, and then Okay, so once we had our calculator, excuse me. So once we had our calculator working, we went ahead and added test cases against this function. We did positive, positive test cases, positive, negative, negative, negative. We did a couple of test cases for 0. And we said that the code that we have already written, it is working according to this input data. Test-driven development is a little different. And to understand why it is different, we might have to talk about the software development lifecycle as well. So SDLC stands for Software Development Lifecycle. Now, broadly speaking, there are multiple phases to a software. Right? It is going to start with requirement. I'm looking for a good diagram. Right. Let's talk on this diagram here. So as DLC, we are going to start with the requirement analysis. Then we're going to do some software designing. Once the designs are complete, we're going to do implementation. After the implementation, we're going to do testing. After testing, we will find out a few things, and probably we might have to change requirements, or even without the change in requirement, there could be, even without identifying any defect, right? When we put it to production, in the next phase, we are going to do the same thing. When new requirements come, when new expectations from the software arise, there will be more requirement that we're going to design, implement, test, and the software is going to evolve like this. Test-driven development says that before we do the implementation, we start writing some test cases. Right? So let me see SDLC if I can find a matching diagram somewhere. Alright, so let's go ahead and start measuring those right here. So we have requirement, the next block is design, then we have implementation, and then we have testing, and the last block is, say, production deployment or evolution. The problem with implementation and testing is that we can have we're going to flip the order of these elements here. We're going to have requirements at its spot. We're going to design, but then before we write the .NET production code, we are going to start writing test cases, and based on those test cases, we are going to write the implementation of the software, and the last phase stays as is. Right? You can see that the order of these two phases, it is kind of flipped. We write test cases before we do the development, and this method, it goes through three phases. The first phase is the red phase, the second phase is the green phase, and the last phase is the refactor phase. In the red phase, we are going to, there are multiple steps. The first is that our code we should not compile. Okay, we should get compilation error for any code that we are writing. The second phase, it should fail. The test case that we're going to write, they're going to fail definitely. Right? In the green phase, there are two steps. We are going to write just enough code so that our test cases pass, right? And when that happens, we are sure that our test case is working. And in the refactor phase, we are going to write the production code. Right? So there are so these three steps, these three stages that it's going to go: red phase, green phase, refactor phase. In the red phase, first step is that our code should not compile. The second phase is where our code should fail. Right? Then we are going to enter the green phase. In the green phase, we are going to write just enough code that our test cases they start to pass. And when those test cases are passing, we'll be sure that our test case is fine. And then we'll start with the third state, which is the refactoring state. In refactoring, we are going to write our application, the actual production code. Right? So let's go ahead and see an example of that. And for that, we are going to use another um, another set of requirement. We are not going to do the example of calculator. We are going to take example of a complex string application. Right? We have So there's going to be a string app. The string app has a couple of expectations. Number one, we should get the length of input string, and it should do us some form of counting. So count occurrences of a letter in input. Right? So we're going to start with this code, but then for developing this application, we are going to rely on the TDD concepts, and we are going to write test cases before we write the actual implementation. Right. So let's get started. Because we are supposed to write test cases before, we are going to add a new project. Once again, I'm going to select xUnit. I'm going to call string app tests and hit the next button. .NET 5 is fine. And because it's a test case, I'm simply going to go ahead and add the okay. So because we have created xUnit package, we already have xUnit. I thought we'll have to add the package. So a string app, and we're going to start with the should part. So the string app should give length 5 for input hello. Right? Ignore this function name for now. We were going to talk about that more very soon. Now, this is one of those few places where I write comment in my code. I don't generally prefer writing comment because comments they cannot be compiled. There are very few cases where you should be putting comment, where you would want to communicate the intent specifically to the reader of the application. Right? One such intent is these test cases where we are going to do three activities. One is arrange, second is act, and third is assert. In the arrange phase, we are going to declare all the variables. In the act phase, we are going to call the production functionality that does not exist at the moment. And in the assert phase, we are going to compare the values. So let's decide our input string, and input string is say hello. Right? Now, looking at this requirement here, it is saying that the string application should give us the length of the input string. So for this input string, we know that the expected result is 5. Right? We don't have that application yet, but then the way we created our application, we set app equal to new app. Right? The official term when you are doing testing is called SUT. It stands for system under test, and we are creating a string app. So I'm just going to say string app. In the string app, I'm expecting a function that is going to give me the length, and I'm going to say SUT system under test dot length, and I'm hoping that it is going to give me the result. And once again, using assert, I'm going to compare the expected result with the actual result. Now, if I try to compile this code, you already see it that it does not build. Right? And we have probably passed the first stage of our red phase. The type or namespace string app could not be found. Our code, it does not compile. So we are done with this phase, that in the red phase, the code is failing to compile. Right? The red phase is done. We're going to write just enough code that we make some progress. So we are entering the green phase, where let me go ahead and rename this unit test 1 to string app should. We are going to write just enough code that our application starts to build to begin with. I'm going to write string app class here. Right. Because I want it to be accessible outside in a different assembly, I'm going to make it public, and over here I'll have to add a reference to the unit testing demo project. With this reference added, our code is starting to build. Probably it did not find the length function. Let's go and do that. Let's add the length function, but then it couldn't figure out the return type because we had a var on the left. Now we can change it to integer, right? And the code has started to compile. I should be passing actual length and expected result. I can change this length to result as well, just to be consistent. So the actual result is 5. The expected result is 5. The actual result is something that we're going to figure out. Our code has started to compile, and we might have to pass this input string to the string app. I'm going to pass it here like this, and the string app is going to receive through the constructor a string variable called input. Alright, now we are using all the parameters. We have a system under test, and if you look at this section closely, we are arranging all the elements that we require for testing, right? And that's why I had to put the arrange keyword here. Most of the time, through the code itself, I make it sound like English language, but there is no way in which I can say that till these 3 lines they are part of arrangement for the test case that we require, right? There is no way I can change the length function to act function to the name act and expect the same result. So I'll have to leave length as is, and that's why I have put a comment here. Same is for assert. I'm comparing for equality, and probably this is not required, but I want to highlight that this is the end of the act part and this is the beginning of assert, and that's why I put another third comment here. With these 3 test cases added, now if I right click and select run test, right, the code builds fine, but then the test case itself is going to fail. I'm going to select this option, and it is giving us a nice friendly message. It is saying that we got an exception, not implemented exception, and the method or the operation is not implemented because the length function simply is throwing an exception. Right? So we are now, at this moment, we are done with the red phase. We have written enough code that our code is compiling, and our test case is failing now. Now we're going to go into a code which is just enough code to make this test case pass. And the minimum code that you can write for this particular test case to pass is you return 5. Now this is very counterintuitive. If you go to the test case, you have hard-coded the input, you have hard-coded the expected result, and through this function, the length function, you are also hard-coding the actual result. When we are writing test case, when we are doing test-driven development, it is essential for us to be very sure that this test case itself is working fine. And to do that, we're going to do hard coding everywhere, like integer a equal to 5, integer b equal to 5, is a equal to b. It is true, right? Because everything is hard coded. We can see that we are not applying any coding principles so far. It is just hard coding that we are going to compare, and we're going to be very sure that this test case is running fine. I'm going to once again run this test. And this time it is saying that the test case passed. If I go to test explorer, it is saying that these two values are matching. Now we're going to go inside the length function, and anything that we require for calculating the length of this input, we're going to do all of that now. right? Because we are sure that our test case works fine. What I need is, I need this input string to be saved in a local variable. I'm going to say string underscore input, and let's go save that input value. Now I know that string is underscore input dot length. There is already a length variable available that I can simply return, but then I want to make it just a little complicated. So I'm going to say count, and I'm going to write a for each loop for each character in underscore input, right? For each C in input, I'm going to do count plus plus, and I should probably initialize this to a 0, otherwise it's going to be a compile error, and I'll return the count value in the end. Because we started with 0, it is probably going to stop at 4, but let's go ahead and see if our test case captures that. I'm going to run the test case inside Test Explorer. Right, it is passing because it is counting all the 5 values. It is counting, starting from the first character, is going all the way to the end, and it is passing now. Right? So our length functionality is completed. Once again, we can change this fact to a theory, and then fact and theory, they cannot appear together. Look at this error message. Test methods cannot have multiple fact and theory attributes. So we're going to comment this out. We are only going to leave theory, and because it's a theory, it is going to require all these inputs. So first input is the string member. The second is expected result as an integer. We're going to pass these two values, and we're going to leave the system under test as is. So I'm going to comment this part out, and for providing these two values, I'm going to say inline data, and the string here is hello. Let's go ahead and repeat this for a couple of other strings. World is also 5, and hello world with an exclamation is 5, 10, 11, 12, 13. So I'm going to do 13 here, and it is going to run 3 test cases against the length function. And let's go ahead and open up Test Explorer, and I'm going to right click on this and select run. And all 3 test cases ran, and they worked fine. Now let's move on to the second requirement. The second requirement is that it should count occurrences of a letter in the input. Alright. So once again, we are going to repeat our exercise. We're going to start with a fact. We're going to say public void consistency has 2s in it. Alright, I'm just going to change the English a little here because I want it to read like an English sentence. String app should count 2s in consistency. This gives us a fairly good idea of what our arrange, act, and assert phases are going to look like. So once again, I'm going to do arrange, then act, and then assert. In the arrange part, I'm going to say bar input, and the input itself is consistency, and the expected result, because it has 2s, it's going to be s, and I want to have character to find as one of the parameters, and I'm going to set it to s. Make sense? Now I need to create the system under test SUT assigned to new string app, and to this string app I'm going to pass the input. Make sense? Now in the act part I'm going to say SUT dot find character to find, and it is going to give us an actual result. Once again, we're going to put the assert statement, and we expect that the expected result and the actual result, they match, right? Once again, we are in the red phase. We should not have an implementation of the find function, right? Because it's a fresh requirement that we have picked up. If you are seeing, if your red phase is not failing, it indicates that there is some developer in your team who is going ahead and he is adding functions without test cases, or he is building code ahead of time for which there is no client requirement, right? What we have here is a requirement for that application. When we are picking up a new requirement for development, our code should not compile. This is an indication that nobody is doing gold plating. The official project management term is gold plating, that you are building features that are not requested from your application. For a simple string application, you don't want to implement find ahead of time. You only implement this when there is a requirement that somebody is picking up. Alright, so that phase is done. Our code is not compiling. We are going to write just enough code that it starts to compile, and with control dot refactoring option, okay, that method has been created. If you go to the definition, it is once again returning an object. We're going to change it to integer, and we have character to find. Now if we run this test case, it is going to give an exception. Let's go ahead and see that exception in action. It is saying that once again it is throwing not implemented exception, a very good sign that we are not gold plating, we are not implementing features ahead of time. Now the red phase is kind of complete. We are entering the the green phase, and in green phase we are going to write just enough code that the test case start to pass, right? And now sometimes it becomes a lot of work of writing this and then executing test cases. Test cases have a nice option of live unit testing. So if I choose this, it's going to pop open a new window here, and it's saying live unit testing. In the live unit testing, let me tuck this under. In the live unit testing, if I click on the start button, as I am writing code, it is going to execute the test cases alongside as we hit the save button. And in the test explorer, you're going to see those results right away. So let me go ahead and rearrange a few things. So live unit testing is running all the test cases all the time. Now, because we modified this find function to return 2, all our 4 test cases, they are passing. Make sense? So we have completed the green phase. We have written enough production code that our application is passing. And now we enter the third phase. The red phase is over, green phase is over. The last phase is the refactor phase. Now I want to find this character. Once again, I know that there's a find overlap available. We are not going to use that right now. We are once again going to start counting each character in the input. Right? And we scroll a bit. Right. And I'm going to do a if statement if ch equal to underscore input. I'm going to increment the count, and when this is over, I'm going to return this count value here, right? And let's see what this is complaining about. Okay, so I don't want to compare ch to input. I want to compare it to character to find, right? And now notice these red lines here, these green checks here. These green checks here indicates that everything in our test case is passing, right? And we don't have to run this code anymore. It simply knows that it found 2s in consistency. Once again, we can change this fact to a theory. And theory, they require inline data, and our inline data this time is going to be string input and character to find. So I'm going to comment out these two lines, and take the input and paste here. Consistency with a small s, and let's go ahead and search full stack developer. And what I want to search here is the letter E. And see, there are two test cases that are failing. So let's go ahead and explore that. And I found 2s in consistency. We'll have to change this. It name now, because the name and the input they are not in alignment. I'm going to say counts characters in input. Right, and let's see what is failing here. Count characters in input is failing. I'm going to get rid of this part, and let's see the error message. The expected result is 2 and the actual is 3. We'll have to pull the expected result outside as well. Let's go ahead and comment this part out. And I'm going to say integer expected result. And over here the expected result is 2. And over here it is 3. I think I see 3 E's here. And as soon as I finish saving, notice that the test case is executed because of light testing. If your computer is a little slow or you don't want this, you can always go ahead and stop and fall back to the original way of testing. Like you come here and then you manually execute these test cases. Right? Now, let's go ahead and search for a D inside this particular requirement. And there's one D that I see, but then this test case is going to fail. Right? And I might have to execute these test cases. And then exactly one test case failed, that the expected was 1, but then the actual is 0. Because we did not have a requirement of doing an case insensitive search, we did not put it in our application. So let's go ahead and start with adding requirement first. I'm going to come here and mention count should be case insensitive. Now, like any other red green refactor phase, we are already in the red case where our test case compiles, but it does not pass. So a failing test case is an indication that the red phase has completed. Now we can directly jump into the green phase where we are going to write just enough code that is going to pass. But we cannot do that right now as we have already moved past that point as well. Our test cases had already started passing for this particular functionality. So we'll have to jump into the refactor phase where we are going to modify or write the actual production functionality. Now we are trying to compare character, and character comparison is supposed to be with the new requirement is going to be case insensitive. A capital A in the ASCII code is 65, the code is 65, and the hexadecimal equivalent is 0x41. If I convert it to binary, 4 becomes 0100 and 1 is 0001. And small a is ASCII code 97 and hexadecimal equivalent is 0x61. And if I convert this to binary, it is 0110 and 0001. Now, if you notice that only this bit number 6, is different here and all the other bits are the same. If you remember the truth table from the digital electronics class, when you want the output to be 0 for different input, we'll have to use an XOR gate, and when the input is same and we still want the output to be 0, we'll have to use the XNOR gate. In high-end processor of Intel, like the 386 series, there is another instruction for insensitive comparison, which is called CMPI. It does case insensitive comparison of the values associated with it. Now, this thing on the .NET side, it translates to a flag in the string comparison, which is called string.switch. Unfortunately, there is no such switch of ignore case in the character case. So we'll have to run this character and this character through another helper function in the character class, and it is called toLower, right? And we'll repeat this for the character to find as well. So now that they are both in the different case and our live testing is on, this test case started passing. Now it is finding out uh, a case insensitive search for the letter D. Let's go ahead and play around with a couple more values. I'm going to change this full to all capital FULL. Now we have two L in the capital letters and one L in the small letter. If I search this, the count should be 3, and with this value all the test cases passed. And if I look at the live test result, it is going to showcase that in full it was able to find 3 results. So now this code is working